leading into arcuate artery here. Then, branching off of that arcuate artery here are these two red vessels. Interlobular arteries. Good. All right, well, coming off of an interlobular artery, we're seeing a vessel go into the corpuscle and then one coming out of the corpuscle. And if we slice that corpuscle open, we're now over here on the model. Here's the vessel leading in, called what?
Afferent.
Afferent what? Not artery, arterial. Afferent arterial. If you just write afferent, afferent what? Afferent impulse? There's many things called afferent. So don't just write afferent. Afferent arterial. This is? There we go. Efferent or efferent arterial. Good. What is the ball of blood vessels in between those two? Glomerulus. Good. All right, we just named all like the arteries coming in. Let's also see that there are two other capillary beds besides the glomerulus. One is right here in the medulla. Vasorecta, meaning straight vessels. There's also one capillary bed here. Peritubular capillaries, always here in the cortex, right? This layer, which is the same as you're seeing here, is the what again?
Cortex.
The cortex. All of this is the medulla. What's one of these structures included in that medulla? A pyramid, and the other structures are? Columns. Good. What is the name of the bump at the tip of a pyramid? A papilla. Good. Urine draining through one of those pyramids goes through that papilla into one of these spaces, a minor calyx. As you then start to merge a couple of minor calyxes together, you get into a slightly larger space, major calyx. Once you're in the middle of all of that, renal pelvis, rectal, little different, just a little. And that renal pelvis drains into what tube? A ureter. Good. Of course, I won't bother going through all the veins because every artery we named coming in, there's a matching vein going out except for one. What artery exists in here for which there is no vein? Segmentals. On the way out, you've got interlobular, arcuate, interlobar, but you skip segmental vein to go straight to this blue vessel here.
That's the renal vein.
Renal vein, right? So almost all the same as the arteries, except for the one thing, there are no segmental veins.
Professor, quick question for you.
Sure.
Those two pieces hanging off the efferent, are those peritubular as well, or you won't leave
That's the
them there?
beginning of the branching of peritubular,
You wouldn't
but I
leave
would
that.
rather, if I'm going to ask peritubular, I'll ask it at the whole bed, not just the beginning of it.
That thing on top of the,
We'll get to that. Let's get through this region first. Okay. The next thing we have to be able to do is name the types of nephrons and their parts. So what type of nephron is this, considering it doesn't have as big of a loop of Henle? Cortical, whereas this one has a long loop of Henle, juxtamedullary. Okay. Then we have all the parts of the nephron. If I'm going to ask you a part that wraps around the glomerulus, I'll do it over here. What part is this? Bowman's capsule or glomerular capsule. Then, for example, if we use this nephron, right after that Bowman's capsule, there's a highly folded region of tubing called what? PCT. We then go down the what? Descending limb, and then turn around at the loop of Henle. We then go back up the ascending limb to fold again as the DCT. Multiple DCTs of many nephrons will all drain into what structure? Collecting duct. Exactly. It was plasma in these blood vessels. What is it called when it's in these nephrons? Filtrate. By the time it gets to the collecting duct, though, it's what? It's urine. Excellent. Nice. Okay. All right, so that's everything here. Let's now jump over here. What if you were asked to name the cell types seen here? Podocytes, like meaning foot cells, exactly. Now, of course, many of you might be at a bit of a distance right now. However, on the day of the exam, if there's an arrow pointing specifically at the little projections of those podocytes, what are those called? Foot processes. And of course, the word projection or something like that would be on the card. Then, there is a space indicated by a squiggly red line. Filtration slit. Good. All right, so that's everything that's in here. Okay, there are two specific receptor cell types seen here. One in the afferent arteriole called what cell type?
JG cell.
JG cells, otherwise known as?
JG.
Juxtaglomerular cells, otherwise known as? Granular cells. That's a stretch receptor, so it's basically measuring what in this vessel?
Pressure.
Pressure, good. Then we've got cells in here that are receptors for sodium. Macula densa, but you're basically then they're chemoreceptors because they're measuring a chemical, the sodium. All right, that may be it. Anyone have their list handy? You do. Just going to see if I skipped anything on this model. Thank you. What's the whole organ?
Sorry.
The last time you
Oh,
mentioned
oh, oh,
something about putting a sticker on the side.
Name the border.
Corticomedullary junction.
Oh.
Yes. Cortico-medullary junction. Good.
Professor, are you going to frame the question with junction in it?
Nope. Name this cortico-medullary junction. No. Name this borderline.
Borderline, okay.
Oh. Oh. Well, it's not on this model. It's okay.
Is there a name for the border of the middle piece? Because you mentioned something last time about putting a sticker on the side. Just don't
Oh, well, someone had suggested that because there are arcuate arteries and veins on that borderline, that we could put it on the side of the model where their vessels aren't there. But my issue with that is that then the sticker might not be so easily visible, and so I don't want people leaving a station thinking, I couldn't find sticker C. So I just assume put it on here and make sure you read the card. Name the red or name the blue is name the vessels. Name the borderline is corticomedullary junction. All right, I think that's it on this model. Everything else is on, other models. Yeah, we got it all. Thank you.
Okay.